In modern venues and businesses, wireless internet functions as a critical operational utility. Security systems, mobile payment terminals, and thousands of guest devices all depend on a continuous flow of data to keep a facility running. When that data flow starts crawling, IT managers often have a predictable reflex. They look for the newest, highest-numbered standard on the market. Right now, that means buying Wi-Fi 7 access points and expecting an instant fix. But throwing the newest hardware at a congested network ignores a basic law of networking. A wireless connection's speed is entirely dictated by its weakest physical link. Every connection relies on the access point, the client device, and the wired infrastructure. Pair a cutting-edge access point with legacy switches, and the pipeline shrinks. It's like dropping a sports car engine into a golf cart. The frame cannot handle the output. We are going to evaluate Wi-Fi 6, 6E, and 7 based on the physical infrastructure they actually demand and the specific environments they fit, rather than their theoretical marketing speeds. Upgrading your access points without auditing the surrounding ecosystem is a guaranteed way to waste your budget on performance your network can't actually deliver. Wi-Fi 6 remains the practical baseline for organizations using standard 1 gigabit internet connections and a mix of older and newer devices. This diagram shows the core advantage. Rather than just increasing top speed, Wi-Fi 6 improves how efficiently one access point communicates. Using OFDMA, it divides a single channel into smaller units, allowing the network to serve multiple devices at once. This makes it the ideal choice for dense but standard environments, like classrooms, hospitality spaces, and offices, where dozens of users share the same airspace. The primary trade-off is spectrum. Wi-Fi 6 operates strictly on the established 2.4 and 5 GHz bands, meaning it doesn't provide access to any new clean airwaves. Look at this building layout. In a dense city or multi-tenant office, your 5 GHz network is directly competing with signals from every neighboring business and tenant. No amount of internal router efficiency can completely overcome an airspace physically saturated by outside interference. Wi-Fi 6 maximizes the potential of older wired infrastructure, but it cannot solve the problem of extreme spectrum congestion. Wi-Fi 6E solves that crowding by extending the same core technology of Wi-Fi 6 into the newly available 6 GHz band. This animation shows the immediate benefit. Since older Wi-Fi generations cannot operate in this band, compatible modern laptops and phones move into a completely empty parallel data highway. This makes 6E a strong fit for hybrid workspaces, dormitories, and zones requiring large file transfers without interference from legacy devices. However, the 6 GHz band is bound by different physical limitations. Higher frequency signals have significantly less usable reach through walls and obstructions. Concrete, glass, metal racks, and elevation changes will degrade a 6 GHz signal much faster than the lower frequencies used by older standards. Because of this, a professional RF site survey is mandatory. A 6E network will not cover the same physical footprint as an existing 5 GHz network using the same mounting locations. 6 GHz is a powerful, high-capacity layer, but it requires precise engineering rather than a simple hardware swap.
Wi-Fi 7 targets extreme data capacity and ultra-low latency, designed for hardware life cycles that need to span a decade. The defining feature of Wi-Fi 7 is the use of massive 320 MHz channels. These drastically widen the data paths available in the 6 GHz spectrum. These massive pathways are required for emerging enterprise workflows, multi-gigabit media production, and high-density AR or VR environments. The primary trade-off is that this level of performance creates an extreme dependency on your facility's underlying infrastructure. To feed a Wi-Fi 7 access point, you need multi-gigabit switches, upgraded category cabling, and significantly higher power over Ethernet capacities. Client devices must also be Wi-Fi 7 compatible. Without those radios in your laptops and phones, the investment in the ceiling remains dormant. Many organizations manage this cost through a mixed design, deploying Wi-Fi 7 in high-performance production zones while using Wi-Fi 6 for general coverage. Deploying Wi-Fi 7 requires a total architectural teardown and rebuild of a facility's data plumbing. Choosing the correct standard requires a diagnostic framework based on your existing building constraints. The first question is critical. Is your facility's wired backhaul and ISP connection over a single gigabit? If the internet is under a gigabit, budget is a primary concern, and you need everyday reliability, choose Wi-Fi 6. This provides the capacity required for standard offices, residential buildings, and broad guest access. If your backhaul is standard but the 5 GHz airspace is heavily congested, and your users have modern devices, choose Wi-Fi 6E. This offers a targeted fix for dense offices that lack the budget for a multi-gig refresh. Finally, if you are executing a ground-up multi-gig build and demand a 10-year lifecycle with enterprise-grade low latency, choose Wi-Fi 7. Matching the wireless standard to the physical and financial realities of the building, rather than the marketing numbers, is the only way to avoid a bottleneck. For large venues and event spaces, these multi-gigabit upgrades represent a significant capital expenditure. To justify those costs, many organizations are shifting from treating Wi-Fi as a pure operating expense to managing it as a cost recovery network. By treating the network as a service, a large-scale deployment can actually generate its own return on investment. This interface shows standard mechanisms for network monetization. Properties offset upgrade costs through sponsored login pages, tiered premium attendee bandwidth, and dedicated exhibitor packages. These revenue-generating controls and network segmentations must be engineered into the original design phase. Retrofitting payment tiers and bandwidth controls after the hardware is already installed is much more complicated and expensive than designing them into the deployment from the start. The most important networking decision you will make is not selecting the access point with the newest marketing label. Analyze your physical bottlenecks, survey your space, and design the right network for your actual people and applications before signing a purchase order.